Walk into any conversation about AI today, and you will hear two completely contradictory things. On one side, the warning that AI is some kind of digital deity in waiting, a mind that will quietly leave humanity behind. On the other, the eye roll and the shrug, the dismissal that all of this is overblown, that what we are dealing with is a slightly fancier pocket calculator. And here is the part nobody seems comfortable with. Neither version is right. Once you peel back the marketing, the panic, and the wall of mathematical jargon, AI turns out to be neither magical nor mindless. It is also not thinking, certainly not in the manner you and I are doing right now. So how does a stack of computer code end up steering a car through traffic, composing a poem, or spotting a tumor inside a medical scan? The honest explanation is going to surprise most people. At the heart of every modern AI system is not some impossible new equation. It is a children's game most of us played long before we could even spell the word algorithm. Surprising histories. Today we are prying open the black box of AI to see what is genuinely moving around inside it. We are going to walk through how it really works, why it stalled for nearly 50 years before it suddenly started working, and the simple childhood game that quietly sits at the heart of everything modern AI does today. To make sense of any of this, we have to start with the way computers used to be taught. For roughly half a century, programming was the job of writing rules. Imagine you wanted a machine to spot a cat inside a photograph. You would have to define a cat from scratch. Triangular ears, whiskers, a coat of fur, 4 legs. Combine those features and you get a cat, the program would say. This worked beautifully right up until the real world walked in. Show that program a Scottish fold, a breed whose ears flop forward instead of standing up, and the rule collapses. Show it a Sphinx, a cat born without any fur, and the system breaks. You quickly realize that no matter how many rules you stack on top of each other, reality always has another exception waiting around the corner. And then, roughly 15 years ago, someone tried something almost the opposite. Rather than feeding the computer a list of rules, they decided to hand it the answers and let it figure out the rules on its own. Picture how a small child learns what a cat is. Nobody sits a 2-year-old down and explains the geometry of a feline face. You point at one and say, cat. You hold up a dog and say, not a cat. You repeat that loop a few thousand times. And somewhere along the way, the child's brain starts catching the patterns on its own. Modern AI is doing exactly this, just at an enormous scale. We feed it millions of labeled examples, and we let it discover its own patterns. Signals so quiet that even the engineers who built the system frequently cannot put into words what their own creation is paying attention to. Which raises the next obvious question. How does a piece of software, something with no eyes and no body and no experience of the real world, manage to find these patterns at all? The answer is something most people have heard mentioned in passing without ever really understanding it: the neural network. Despite the slightly intimidating name, a neural network is not some artificial brain made of glowing wires. It is much closer to a factory assembly line. Picture a long line of stations stretching across a workshop floor, each one passing its work along to the next. Suppose you hand the AI a handwritten 10-digit, say the number 9, and ask it to figure out what it is looking at. The very first station is brutally basic. It does not see a number. It just stares at the raw pixels and asks the smallest possible questions. Are there any straight edges in this region? Any curves over here? That station passes its findings down the line. The second station does not look at pixels at all. It looks at the answers from the previous station and starts combining them. That curve up there is probably part of a circle. That stroke at the bottom is probably a vertical line. The information moves to the next station and the next. By the time it reaches the final station, the AI has built up enough understanding to confidently announce, a circle on top with a line dropping down underneath is most likely the digit 9. This entire setup is what people mean when they say deep learning. The word deep simply refers to the fact that the assembly line has many stations, sometimes dozens, sometimes hundreds. The early stations spot the small details. The deeper ones recognize the large concepts. There is no magic happening at any single point. It is just layers of small, unsophisticated questions stacked on top of each other. But this opens an even stranger question. How does the assembly line know which questions to ask in the first place? And this is exactly where the children's game finally walks onto the stage. When a brand new AI is first switched on, it is hopeless. The assembly line exists, but every station is set to random. Handed a photograph of a cat at this stage, and it might confidently inform you that it is looking at a toaster. That literally happens. So how does a system go from cluelessly shouting toaster to reliably saying cat? It plays hot or cold. You almost certainly played this exact game as a kid. Someone hides a small object in a room, and as you wander around looking for it, they call out hot when you are getting closer and cold when you are drifting further away. Modern AI is trained the same way. Every time it makes a wrong guess, the system fires a tiny cold signal backwards through every station, nudging the settings of each one a little in a slightly better direction. In computer science, those settings are called weights. Picture a mixing board the size of a football stadium, covered in billions of microscopic knobs. Every wrong answer turns a few of those knobs by an almost invisible amount. The AI repeats this loop millions of times, sometimes billions of times, during the phase engineers call training. After enough rounds, the entire mixing board settles into a configuration that produces the right answer almost every time. The AI is not understanding cats. It is not understanding anything. It has simply tuned an unimaginably large bank of dials to react to the visual fingerprint of a cat with the word cat. The intelligence everyone keeps marveling at is really just billions of knobs, gently nudged into place, one wrong guess at a time. That covers how AI looks at an image and figures out what it is. But how about the systems that write essays, hold conversations, or produce full articles in seconds? That world is what people mean when they talk about generative AI, the family that includes ChatGPT and its many relatives. The logic underneath is a little different. Rather than a yes or no challenge over photographs, they play a high-stakes round of filling in the missing word. Imagine for a moment you had personally read every book inside the Library of Congress. If I started a sentence with, "The quick brown fox jumps over the," your brain would deliver the next word almost instantly. Lazy. Why? Not because you ran a calculation, but because you have. He encountered those words side by side so many times that no other word stands a chance. The probability of lazy showing up next would sit somewhere around 99%. Generative AI is essentially that exact trick, scaled to a level no human library could possibly match. It looks at the words you just typed, runs them through a database trained on roughly the entire written internet, and then statistically picks the most plausible next word a human being would produce. It does that one word at a time, faster than you can blink. And here is the slightly uncomfortable part. It is not telling you a fact. It is not weighing the truth. It is calculating the most plausible noise a human would make at this exact spot in the sentence. When ChatGPT comes across as thoughtful or warm or witty, that is not the AI being thoughtful. It is reflecting back all the thoughtful, warm, witty things humans have already written. A statistical mirror held up to us. So when you finally pull back and look at the entire machine, the picture changes considerably. What looks like alien intelligence turns out to be something far more grounded. A tool built on layers of small logical questions, trained through a children's game of hot and cold, fed an ocean of borrowed human experience. AI does not possess wisdom. It carries the echo of ours. It is a simple thing that became complex, not because anyone made it intelligent, but because we let it practice billions of times in a row until the dials lined up. If you enjoyed this peek inside the machine, make sure to hit that like button. It helps our algorithm know you want more content like this. This has been Simple Things, Surprising Histories. Thanks for watching.